So it's the next day. I reckon it must be the 14th today. And it's a Rotel RVC230. Now, this customer's coming here today for other reasons, so I'm going to give him his D'Amico convoy back. And if I can get this done in the next 40 minutes, he can have this and save him a trip. Though we won't be scratchy cornering it. Now, you've all seen Rotel 230s plenty of times, so it's not like people are gagging to see it. So let's hope there's nothing silly inside. Comes with its original mic. It's in pretty normal condition. It's not new, it's not old, you know, it's just 40 years of careful use. That capacitor needs changing. So we'll take the rest of the screws out. Put the soldering iron on. You see, there's always going to be something. It's Saturday today. As a church organist, I haven't got any weddings. It's interesting that one. I'm not going to power the set up till I've changed that. That's in the audio amplifier, if I remember rightly. You see, what's happened, it's got so hot that the heat shrink tubing with all the writing on is actually shrunk. So instead of it neatly being over the top like the rest of the capacitors, it's receding because of the heat, and it can't possibly be working right. And even if it is, well, it's coming out. They have some glue underneath these, so I can't just use the solder sucker. It's also useful to be able to get rid of that glue, although it doesn't normally affect the electronics. It would if it was valve equipment. You can end up with tracking underneath. So hopefully that's unsoldered enough and it's just the glue holding it. So positive is shown to the left. Just want that out of the way of the leads. So we're looking at 1000 at 16 volts. We do have them in the general kit. Bit of a size change, isn't there, over the years? So unlike the Uniden sets, these aren't that prone to capacitors failing unless something's happened, like being overvolted. So we'll get that on the capacitor tester, or the SR meter. See if it's still got some microfarads in it. I'm going to put that bottom case back. We'll just put one screw in. It can help with the tuning. It can end up with a capacitive effect. I mean, it could have been strangled audio, this. with this part in or no audio. Without doing my maths, I don't think that's right. Anyway, it's not. It's going in the bin. We've got a power stub, haven't we, for these? So we'll plug the SW711 speaker mounted on the wall into PA, and the test instrument speaker, when we find it, test equipment into the aerial socket. Oh, he talked to me on this radio on his way, so we know the radio actually works. I should realise that when it was still on channel 31. Right, we'll check that VCO first. So we'll set the radio on channel 40. I think they're about 46 pence, those capacitors. So we want to put one clip to chassis. Far end of resistor 4, and we're looking for 4 volts. On receive, we're looking for 4 volts on transmit. We haven't got 4 volts on transmit. You can end up with channels dropping off at the extremes, like a radio that won't do anything under channel 6 or nothing on over channel 36. That's the result if the VCO is out in different temperatures. So we'll just check that it's still correct on receive. So it was 3.94. Stroke 2.94, so it's now 3.94, and back to the transmit one, 3.98. So we've done that, but we're just going to check it on channel 1, where it should be somewhere around 2.2. So there's our receive, 2.19, and there's our transmit, 2.25. Absolutely wonderful. So that's that done. Easily overlooked. It's not something which really drifts out that much on these sets. It's not like the other Cybernet chassis used in the Amstrads and the Mustangs. That's much more prone to shifting. Right, so we need to go back to channel 20. And let's see what the radio is doing on transmit. It's just doing 3 watts. And on low power, he's doing 110 milliwatts. So back to full power. It's drawing 980 milliamps. And on channel 1, he's doing 3 watts, and on channel 40 he's doing 3.05 watts. best if they're within 0.1. Not always possible. So we've changed this test set into its 30 watt scale. So now we're looking at, I've not got the running picture in picture on again. So we're now looking at, that's 3 watts, that's 4 watts. What am I doing? We're on here. I tell you, it's only 7 in the morning. Little bit of adjustment on that last one. Now let's see if the VCO is going to play not having broken cores. So we need to set these to all to peak. Just as a temporary measure. So this one, it's about 4.5 watts. Whilst it cools down a bit, I'm just going to set the, let's just see where the deviation is according to this test set. Wallow, it says it's 1. So I just want to set, we're going to verify it with the test set behind me. I want to set that to centre. We'll just set the deviation roughly on this. That should be about there. We'll verify that in a bit with the test set on the other bench. Sometimes this isn't true, it's got capacitor issues. Right, so back to transmit power. Now I'll tell you what, we'll do frequency because again I'm wanting it to cool down a bit. So it should be 2779125. I've gone and done the whole tune-up on channel 40. I'll have to start again. 2779085, bring that up to 125. And reset all these. You know what, I could have sworn on a stack of Bibles I'd turned it to channel 20. Right, I'm going to move over to the receiver because I've just double warmed that up. Your power drops as the set gets hotter. They're not made for continuous transmit operation. It's only something like 5% duty cycle. I'm not just saying these sets, most sets. Right, receive. Let's go over to the, we're on the signal generator, so we're on 2779125. We've set it up now. We'll do the receive and come back to transmit. Right, there we go. So with the SINAD meter on, for 12 dB, 4.5. For 10 dB, got 0.39. For 20 dB, we've got 1. Squelch at full. Is 27 microvolts, which is too slack. And at threshold, is 0.9. Right. So over to the detector. So we'll look at the oscilloscope. S9 equivalent signal of 100 microvolts. And that needed a little bit of adjustment. So now over to the SINAD meter. We'll see whether we can get a bit more out of the receiver. Wow! We've got an extra scratchy corner out of this. Just put a bit higher signal on for these IF ones. Sometimes you get the extra circuit in receive on these, sometimes you don't. This is the sometimes you don't one. Yeah, everything else is fine. So we'll get a new reading. So there's 12. We've now got 0.22 microvolts. At 10 we've got 0.2. Nearly as good as that D'Amico convoy we did. And for 20 we've got 0.55. What a great set. So turn the squelch to full, and we'll adjust that squelch preset. Actually, it's come right. Oh, not quite. Now it has. It didn't need much adjustment. It was 80 microvolts, so it had changed from 27 microvolts to 80 microvolts quite simply by retuning the receiver. That'd be that detector which was out, because squelch is usually on the 455 IF. Right, let's have a look at threshold. So we'll put the signal generator to standby, set the squelch threshold, signal generator on, 0.65 microvolts. So there's the interesting point. I've made the squelch preset weaker. Sorry, I've strengthened up the squelch, but in fact the low figures come down. the upper figure's gone up because it's come right because I've retuned the set. So it just goes to show what a difference that can make. So let's go back to transmit and see whether we can get the set to be somewhere nearer 4 watts. So we need to where are we? Look for the blue trim tool, there it is. We need to be adjusting this one, making sure we're still on channel 20 for 4.4 watts. You see, I've had to let this cool down because the radio was only doing 4.4 watts. And it's vital you can do this adjustment at 4.4 watts, so it's never going to balance properly. So key up 4.7. So we can bring that down to 4.4, and then they want you to, that's by turning that one clockwise, that stays where you've put it, and this one turns anti-clockwise. So the manual says 3.8 watts, but we allowed 4 watts, so we adjust it till we've got 4 watts. Remember, they have to get these things through customs, and that's why they have you set them low. And that's why nothing has changed, and they're still set low. So we now have full 4 watts on channel 20. Right, let's play with the channel selector. Channel 40, 3.95 and a bit. Channel 1, 4. That's great. So, channel 20, see what the power consumption is, 1.18. Now we want to just set low power, set the radio to low power. I think that wants a quick spray, they often play up. .400 milliwatts, which is what it should be. Right, back to high power, and our transmit should be on the 4, it's just over. Just like that. And on receive, the meter for 100 microvolts should read 9. And look at that, it is absolutely spot on the 9. If it needed adjustment, we'd be adjusting the preset there, but it doesn't. We haven't checked PA. Testing 1, 2. Now we have. I'm being attacked by some mad paperwork and the lid of a CB. That's another really nice set. So if you don't address things like that capacitor in the audio circuit, apart from the fact it's going to sound more and more strangled, it will eventually kill the audio IC. What are they, 580, something like that? You've got to get them fitted. You know, so it's the stitching time saves 9. Just observe things like that. So I think they're 46 pence, those capacitors. It's no big deal. But it would so easily kill the audio IC if it got worse. And although the customer was using this to talk to me as he came last week with it, I'm not brave enough to switch sets on without having looked inside them. It's amazing. He comes out with quite a few nice sets. Although he's a business customer, he's a full licensed radio amateur. But he has a nice collection of UK CB radios as well. Probably does what some of the other people do and has CB of the week in his car. So I doubt this is going to see scratchy corner test because we'll be giving it him back in an hour's time. But we'll go on the air and see whether any of these good buddies at Nottingham, or even the bad buddies at Nottingham, can be heard 35 miles away on their naughty radios. I put the lids on, I need to verify the deviation, don't I? One Anna, Roger. Would I be right in thinking that they haven't got out of bed yet? Do you think that's a CB thing? Staying up in the early hours. Right, I'm just going to plug it back into the test set behind me this time and just verify the deviation. So may as well may as well switch the test gear off, and we'll just listen to this into our hand portable. Testing 1 2, testing 1 2, testing 1 2, testing 1 2 3. Good, there we are. That's it. Rotel 230, a really nice example. Thanks for watching.